Hello everyone, I'm Charles. We'll be talking today about deep learning and computer vision, trying to give you a good understanding of what's easy and what's not so easy in that field. Before I start, just a little bit of background on me. I did a PhD in machine learning, and then I founded my company Heuritech. And I am also a teacher in deep learning and machine learning at several masters, data science master, EPITA, etc. And all the lectures I give are open source and available with Jupyter Notebooks, labs. It deals with computer vision, recommender systems, NLP, etc., etc. So feel free to go at this URL and try all these lectures. It's all in Python, Keras, and with a little bit of PyTorch as well. So about my company, it's a company I founded 4 years ago. We do mostly text and image and also video recognition using deep learning. I will be talking a bit more about it. And we have decided to focus on one specific domain, which is fashion. I will explain exactly what we do with fashion. But globally, what we do is we spot trends from millions of images and videos. So we gather every day millions of videos, millions of images, and we detect the different aspects of fashion, the colors, the patterns, the different products, etc. Today we are 28 people. This gives you a bit of an idea of how to build such a quite big machine learning system in production. What kind of team do you actually need? So this could be a bit different, but here is the team that we have, mostly technical, with plenty of back-end engineer, DevOps, many people in research and development, including some related to academic research in a PhD. So all together building the core of the team. But I won't talk so much about Heuritech. What I want to talk about today is how to build an AI vision system. You could have plenty of different options on what you want to build. A classification system, as was described in the previous talk. You might want to detect some I don't know, diseases from pictures of the retina, from some pictures of the skin, etc. There's plenty of application of computer vision today, or tracking of vehicles. And if you start to build this system, you have plenty of options today, and it's quite hard to know which one to try and what will be the difficulties. So this is what my talk is going to be about. So first, what you should consider is generic APIs, pre-trained APIs, such as the one that was described in Amazon Rekognition. Every big internet company has its API nowadays. You have Google Cloud Vision, Microsoft Azure, etc., etc. So these APIs are available, pre-trained model, really easy to use. They scale really well. So if your problem fits within that, great. Do that, don't try to build the system. The only problem is that usually, and in most of the case, your problem won't fit in these APIs. With image recognition, you might want to detect faces, and then these APIs are really good at detecting faces. But if you want to do specific tagging, disease recognition, specific classification, tracking, etc., these APIs are not really don't really have any use. So you will have to rely on building your own system quite a lot of time. So building from scratch, you're going to see it's going to be quite difficult. However, these days, it seems that deep learning, everybody's talking about it. It's easy. We can just take the pre-trained models from Keras, put them in production. I can make a demo in 1 hour, have a service, a demo service. And there's plenty of available algorithm. So let's dive into this and see if it's that easy. So first of all, deep learning for image classification is always based on these deep neural networks, such as the VGG, which is not state of the art nowadays. You have the DenseNet or the ResNet, which are better. I won't describe exactly how it works, but basically, you have an image as input, several layers that you can train to transform your input space into an output space, which could be, for instance, the classification here on the ImageNet. Among 1,000 of different classes, you have to pick the best classes that matches the image. So the good news is that this is available everywhere. You can pick it. Every framework will have a demo with this one. The bad news is that usually classification is only one small part of the problem. If you have a single object and you're trying to detect a single thing within your image, then you're doing classification. But you could need to have information about where the object is. This is called localization or detection. You can have multiple objects. So for instance, you're not only tagging that there's a dog in this image, you're also tagging forest, also tagging plenty of different things. So this becomes a multi-way classification. And this is much more difficult than standard classification, actually. Not because of the algorithms, but usually due to the difficulties to gather a good data set that represents this problem. And then you can go towards even more interesting problems. Object detection. So there's multiple objects. You want to detect all of them. Multiple instances of cats. Here, for instance, not only saying that there are cats and drawing a box around the cats, but identifying each of the different cats in the image. And finally, the grail of image analysis would be instance segmentation, finding all the pixels that belong to one specific cat in the image for each of the objects. So this is used, for instance, in autonomous vehicle driving. There's a lot of data sets where you have a picture taken by the camera, onboard camera of the vehicle, and you want to identify where are the pedestrians, the traffic signs, etc., etc. So when you have that, the good news is that you can still use the canonical deep learning network that you have available, pre-trained for you, very well defined, and just plug on top of this network the new building blocks. And by using Keras, TensorFlow, PyTorch, all these frameworks that are available today, it's quite easy to take the pre-trained model and add on top of it some new layers to do, for instance, multi-class classification, so tagging, instead of just one-way classification. This can be done really easily. To add several layers that produce bounding box coordinates to do some detection or localization, to add the masks to do segmentation. It's quite easy today to modify the architecture. It's not really a matter of architecture that is difficult. What could be more difficult is to gather the right data set. Because here, when you need to train such a system for detection or segmentation, for instance, you need a large data set of hand-labeled segmentation masks, such as these ones here, which means that you need to build interfaces, you need to build processes to have people drawing these little boundaries for you and gathering all of that in a big database before you can train the systems. So the difficulty here becomes more the building of the data set, the treatment of all this data process, rather than using the pre-trained algorithm or the predefined algorithm that you can find today a bit everywhere in many different frameworks. So having said that, I just wanted to share a bit the state of the art of what you can do with image analysis using deep learning. One of the last from last year model was called Mask RCNN. It's a model which does detection, so identifying all the different objects among 80 possible types of objects, such as a person. There's plenty of objects, plane, person, etc., etc. And from this image here, outputting all the different boxes which correspond to these objects, and even binary masks which define where the object is exactly. So not only the box, but the mask. So this is instance segmentation, works really well, really impressive results. And you have implementation from Facebook and from other companies which are open source and available on GitHub now. So the results, I always share these results because they look really impressive to me. This is an image with a few people which have been correctly identified and their surfboards have been identified. But the reflection, on the reflection, nothing has been identified. These are 3 horses, and even though they are behind the fence here, the model still accurately said that there was 1 instance of horse, 2 instances of horse, and 3 different ones. So there's patches of pixels, but it correctly matched the good patches of pixels which correspond to 1 horse, and did not mix these 2 together or these 2 together. So this is actually quite impressive, because we've never shown a lot of images of horses behind the fence to this model. You just generalized pretty well and gave this output. Even on pictures with different scales or objects with angles, this model behaves quite well. Good. So we have a really good model, open source implementation. We just need the data set. Quite a hassle, but could be handled. So are we done? Can we build our algorithm from scratch and deploy it? Actually, there's more to it. There's a long history of people deploying these models to actual services, and we had a whole talk on it with Amazon, but there's plenty of other ways to do it. We did it internally at Heuritech, so there's a big part in deploying, which is big, but there's also plenty of parts which are a bit more hidden, which makes this problem difficult. And I'm going to make a little quiz for you to give you a bit of insights of why these things can be hard. So I've taken 4 tasks. This one, the input is traffic sign, the data set traffic sign, and the output is 40 classes of different signs. The second task is diabetic retinopathy. It's a disease that you can accurately see from a picture of the retina. So the input is retina images. The output, to simplify here, is just, let's say, sane or the person has the disease. The third one that I gave is you have this picture, a random picture from Instagram. You have to detect the handbag. And the fourth would be you have a photo of a shoe. You have to detect which model of shoe. So this would be the, I don't know, Nike something, Nike Air something. So which ones are difficult? Which ones are easy? Anyone? OK. I can say the first one is actually quite easy. The first one, we get up to 98% accuracy on the validation set. And it's really well defined. It's on a very coherent data set of only traffic signs. And it works really well with modern deep learning techniques. So this one is actually quite easy. The 3 other ones, here, are much more difficult. First, this one should be quite easy because you will get towards high accuracy during your training phase. But the difficulty here will be handling a huge imbalance between the sane cases and the disease cases. During tests, you will have most of the cases which will be sane, and very, very few which will be disease. And you will need to get towards really, really, really high accuracies during your training so that your service is actually useful in production. Otherwise, you will get so many false positives that it will be difficult to handle. So this is difficult because of the imbalance that is naturally in the data, in the test data. But still, we can have really good models of that with high accuracies in test. OK, now for the third one. Well, maybe let's start with the fourth one. Why would that be difficult? Well, it's a classification problem. You have plenty of shoe models. But what is difficult here is that you also have plenty of images that have that are shoes, but maybe are not within the 500 classes. So plenty of negative images that your model will try to fit within one of the 500 that you defined. If I define, for instance, I'm working with a few brands, and I define 500 classes that correspond to the brands I'm working with. Plenty of other pictures that could be taken will be matched wrongly to one of the categories. So it's difficult to handle the waste, the total negatives. And you have to be quite accurate, because here you have the Nike sign, but with different angles, you could not see it, and maybe you should still be able to see what kind of shoe it is. So a lot of variability for one class here. Okay, and the last one here, bag detection on photos should be quite simple. We've seen all the examples here. Looks like so accurate. Actually, it's really hard. And it's hard for two reasons. The first one is we are testing on a huge domain. Instagram, there's a lot of different types of images. It could be anything. So it could be fashion images, but it also could be whatever. And the second is defining a bag. Actually, a bag could be anything, any shape. Could be hidden, could be taken by the hand. It's difficult to define a bag, actually, because there are so many different types of bag. So the definition of your class is really wide. It's not one single pattern that is easy to detect, that the neural network will easily grab. It's plenty of different patterns. So because the domain is wide and the class is not well defined, this problem becomes difficult. And here are a few examples of what our first models detected. This actually looks like quite normal bags. It's held by the hand. It has a triangular shape. It's brownish, could be leather. So actually, it's quite normal for a model to say that this is a bag, actually. We never showed images of axes to the model during training, obviously not. So why not? And this is why it's difficult. When you're in the wild, which means you do not have constraints of domain of input, you will have these images that pop up and count as false positives. So when you have very broad diversity of images, a lot of classes which are maybe too wide, and very different scales or shapes, the problem becomes really, really difficult. Much more difficult than identifying a disease from an image that is always exactly taken in the same kind of position, etc., etc. Okay? So this is quite complicated. But you can have plenty of procedures to mitigate that, such as active learning techniques. So these are the kind of images that you will label by hand and put back in your system to train it next time. You take the false positive, you relabel them. A human says, okay, this image is actually not a bag, and you use this information. It's quite tricky to do. For classification, it's quite easy, but for localization, it's actually quite tricky. You have to change the way you build the losses of your network, usually. And there's also plenty of other options where you can make a lot of data augmentation, data generation to generate plenty of edge cases, which will augment the data set and make it more robust to this kind of things. Right, so generic API only for some very specific cases. Starting from scratch, good luck, but it's possible. Specific service, that's what we decided to do at Heuritech. We decided to focus really on one specific field and tackle it. And I think a lot of different startups in vision will emerge, tackling some specific spaces really well, and this will be the case. So we decided to go towards fashion, as I said. So fashion is difficult because there's so many different types of images. And here is, I think, one of my last slides, the kind of pipeline that we have to analyze an image. We have this as an input. We first identify the context through a deep learning model, which will give a global tags on the images. Is it in the street? Is there a person? Etc., etc. So each block here is a trained deep learning model. We have plenty of deep learning models in production. Each of them is within a container. And to process one image, we will run them through all of them. Then we have the detection algorithm, which will produce the little boxes around the different parts of the image. Segmentation will produce the masks and different classifiers, which will identify exactly the model of the handbag, the different colors, the different attributes. And here are the different things we can identify accurately in the wild, so with very, very different kind of images. So such as the name of the brands, the style, the shapes, even the model of the shoe or the texture of the bag. Okay, so thank you very much. And I'm not sure.